NCAT's basic mission is to validate and develop new technologies for improving roadways to make roads smoother, quieter, safer, last longer, and more economical. The test track is our proving ground that we use to help validate those technologies in accelerated fashion.
When we started the test track, we could not run tests in the laboratory and run analysis in the office and predict performance. The only way to be able to determine performance was to build test sections and to evaluate the quality of these test sections under traffic.
There are no other facilities that I'm aware of where actual test pavements are built using materials that are local to each state's jurisdiction, and then real trucks using realistically loaded axles are used to apply a design lifetime of pavement damage compressed into a 2-year cycle like we do here, so that we can turn results around very rapidly for state DOT sponsors. And in order to accomplish that work, we run a fleet of heavy triple trucks 5 days a week, Tuesday through Saturday, from approximately 5 in the morning to about 11 o'clock at night. So for each section, we measure roughness, rutting, and macro texture every week. And then there are some other tests that we run every week, and then some tests we run monthly, for example, surface friction. And then some tests we will run quarterly, for example, destructive coring.
Most sponsors of test sections have wanted to evaluate very specific issues, maybe comparing one aggregate type to another, one mixed design type to another, maybe one pavement structure to another, and to evaluate which one is better.
ALDOT has participated in the test track since the original 2000 track was built, and by doing so we've been able to collect through the structural section significant data, and that data was recently been able to be used to develop a model to predict what a structural layer coefficient would be, specifically geared around Alabama's materials.
The study to revisit the asphalt structural coefficient was initiated by the Alabama Department of Transportation. The value that they had been using, which was 0.44, was based on the early road test that was conducted in the 1950s, the original ASHRAE road test. And so that number had really not been updated since the 1960s. Well, we've had a lot of advancements since then in terms of super paved mixed design, tighter specifications, performance graded binders, and yet we're still using that number, that 0.44, which means we still design the pavement at the same thickness as if we were using the older technology. And so we were able to use test track data to recalibrate the structural coefficient. The number that we came up with in that recalibration study was 0.54, and the net result of that change is a reduction in asphalt thickness of about 18.5%, which if you spread that over a resurfacing program or new design across the whole state is a huge savings and great benefit to the DOT.
Which allows us to stretch our dollars a lot further and maybe even have more projects.
Mississippi's in a very unique situation when it comes to aggregates. We don't have a lot of locally available limestones and granites. We do have a lot of chert gravels, which a lot of states disallow for use in their pavement mixes. The NCAT track has allowed us to rapidly test those pavement mixtures with chert gravel. Because of that rapid testing, we've been able to promote that mixture for use in MDOT projects right now.
On the first test track, ALDOT sponsored several sections where we compared coarse-graded mixes with fine-graded mixes. By sponsoring these sections on the test track, we were able to compare these two mixes against the same heavy traffic loads, and we're able to determine that our fine-graded mixes performed equally as well as the coarse-graded mixtures, thereby allowing ALDOT to use the normal fine-graded mixes that we have been accustomed to with the materials we have here in our state.
We've built on the test track sections with a range of wrap contents from 0%, 20%, 40%, even 50% wrap. Some of that work has been aimed at trying to identify what binder grade we need to use in different wrap content mixes.
What we've learned with the high wrap with the warm mix asphalt is that these mixes can be produced and they can be placed without any major issues at all. And also we've learned that these type mixes show little or no signs of rutting and are performing well to date.
Our section is section N7 on the north side. Our goal with this text section was to determine if a highly modified binder would allow us to reduce the total pavement thickness and still achieve adequate and even superior performance. So our goal was to simply change the binder and not change any of the mixture design, so we kept the same gradation, kept the same mix design, and simply replaced the binder. And so that gave us a total pavement thickness of 5 3/4 inches versus 7 inches for the control. And so far, the results are looking good. We're seeing very limited rutting, less than in the control. No cracking so far, but there's no cracking in any of the structural sections, so far so good.
A lot of sponsors are very interested in continuing evaluation of sustainable pavement technologies. Things like higher wrap contents, using shingles and ground tire rubber and other sustainable technologies, as well as things like warm mix.
As state DOTs deal with budget limitations, at least in the short term, pavement preservation is going to become more important for state DOTs, and I anticipate that that's going to become a bigger focus of research on the track.
The Alabama Department of Transportation is currently gearing up to move to the Darwin ME program. The track is ideal in that situation because basically they build out their smart pavements that can tell us exactly what the materials are doing while they're being subjected to continuous loading cycles. By being able to characterize so completely our materials, we're going to have some very good level inputs to go into the MEPDG.
I was very blessed to have a 12-year career with Alabama DOT before I came to work at NCAT. And one of the things that I did for the state of Alabama was to execute pavement research of the type that we do here on the track, where we had test sections that were scattered throughout the state. You didn't have exact traffic numbers after the pavements were open to traffic. The climate from North Alabama was different from the climate down in South Alabama. You couldn't get out on open roadways and do extensive and frequent pavement management studies. It was just very, very difficult to kind of wrap your arms around those types of questions. And that really is the value that the track provides. All those confounding factors are all controlled here.
The test track allows us to have a focused research effort that we would not be able to get within the department by ourselves.
We could not do this sort of research study on one of our state roads because of the magnitude involved and all the coordination that it would take to do something like that. And also we would not want to take the risk of doing this type of project because if we had a failure, then we'd have to delay the traveling public.
I'm very pleased with how extensive the testing and analysis is that the NCAT research team is conducting on the materials and on the sections. There's additional testing which we don't really expect to have an impact and make a significant change, such as noise abatement and reflectivity, but still having that data is very nice because those questions eventually will come up and now we will have all those answers.
So the track has been great so far, and there's many, many things we can look at in the future, and the only way to do that is with the test track.
There's no such thing really as a failed experiment here because we learn something from everything that we do.